Hey guys, welcome. Yeah, so a few videos back we learned about one type of vector multiplication, the dot product. In fact, since we've learned how to calculate the dot product between two vectors in a couple of different ways. And this time in this video we learn about the other type of vector multiplication, and it is the cross product. And the two types of vector multiplication are very different, not just in the way we compute, which is not just in the way that we find the dot product versus the cross product, but also in the fact, for example, that the dot product gives us a scalar, it gives us a number. So when we take two vectors and we do the dot product between them, we get a scalar or a number, whereas the cross product, the subject of this video, gives us a vector. So the cross product between two vectors is a vector, whereas the dot product between two vectors is a scalar. All right, now before we do anything, let's look at this very important visual. Now, the cross product doesn't just give us a vector, it gives us a vector perpendicular to the original two vectors. Now, suppose you have that a vector u here and a vector v meet at their initial end right here. Then there's only one plane that contains both the vector v and u. And when we do u cross v, we get a vector perpendicular to both u and v. Therefore, in doing u cross v, we get a vector that is perpendicular to the plane, which is really cool because in a couple of videos, we're going to be learning how to write the Cartesian equation of a plane, and therefore, the cross product is going to play a prominent role. In fact, the way we're going to determine the direction of a plane is by finding two vectors in the plane and then doing their cross product, because only one vector up to scalar multiples can be perpendicular to a plane. So, like for a line, the way you find the inclination of a line is by doing rise over run or its slope. But you can't just find a line in a plane and do the inclination of the line, because that's not sufficient to determine the inclination of the plane, because you can spin a plane about a line. So the way you determine the inclination of a plane is by finding a vector that is perpendicular to the plane. Because remember, vectors don't have a set location, so you can move the vector anywhere about your plane and it's still going to stay perpendicular to your plane. And the only vectors different from that vector that are also perpendicular to the plane are scalar multiples of that vector. But what we're saying is like a vector perpendicular to a plane is unique up to scalar multiples. All right. Let's go on and see how we do this in practice. In practice, we take two vectors, let's say in 3D, these guys, and to find the cross product, we do the determinant of this matrix. The determinant of the matrix whose first row is the unit vectors I, j, and k, and then the second row is either the vector u's components or the vector v's components. It doesn't matter which you put in the second row and which you put in the third row. But yeah, you do the determinant of this 3 by 3, and I'm already indicating that we're doing the determinant by these vertical bars in case you're not familiar with matrices or determinants. But yeah, you have to do this 3 by 3 determinant to get the cross product between u and v. And again, once you're done, what you get is a vector that is perpendicular both to u and to v. And yeah, like if you don't know how to do 3 by 3 determinants, I already have a video which I'll try to link below this video at some point. But yeah, you can also Google search it and you'll find it. And there are other great videos on YouTube on 3 by 3 determinants, I'm sure, so you don't have to watch mine. But yeah, watch them and then you'll know that what you do is this. Well, let me teach you the process really quickly. Yeah, so here's how it goes. So like basically you take this first column and first row and cross them out, and then you have these four guys left, and that's how you get these guys, these four guys, first four guys. And then here for these four guys, what you do is you go to where j's at, and then you cross out the row and column containing j, and then you get these two guys here and these two guys here, and that's the four here. And then the last four, you probably could guess it at this point, you go to k, cross out this first row and then this third column, and you get these four guys here, and that's these four guys. And so in the process of doing the determinant of a 3 by 3, you end up doing 3 2 by 2 determinants. And 2 by 2 determinants are easy. You multiply diagonally these two guys first. So U2 and V3 here in this first one. And then after you multiply these two, you multiply these other two diagonally, and then you take the difference. So you do U2 times V3 minus V2 times U3, and you do that for this other guy and this other guy. And you also have to remember that in the middle you have a minus sign. Otherwise, you know, after doing the 2 by 2 determinant here, you multiply by I, and then 2 by 2 determinant here, you multiply by J, and then you do your 2 by 2 determinant here, and you multiply by K, and that's how you do it. So basically, in short, very quickly, I just taught you how to do 3 by 3 determinants, and what you'll end up with is here. Obviously, when you're actually like aware of the numbers in here and the numbers in here, this simplifies like tremendously, right? When you're actually working with numbers. But yeah, for now, we can state this guy here as the formula for the cross product. But I really don't like memorizing formulas, let alone formulas this long. So what I'd advise you to do is learn how to do 3 by 3 determinants. It's really easy. I taught it to you in this video. And so once you learn that, then, you know, put your numbers here and then do 3 by 3 determinant, where maybe you have to write this step, but, you know, you could probably do it in your head after a couple of practice problems. Yeah? Okay, cool. Speaking of which, let's get on with one practice problem, and then I think we're done here. Learning how to do the cross product and also the idea behind it. So here's the example. Suppose we start with these two vectors. Then, this is a 3 by 3 determinant we'd end up with. And we actually do the 3 by 3 determinant, and that's the process I just described. Now notice that the determinant of this matrix here and this matrix here are both 0, because here you'd have to do 0 times -1, which is 0, minus 0 times -4, also 0. So 0 minus 0 is 0, and then times I is still 0. So here in the middle you get 3 times -1, -3, and then minus 2 times -4 is -8. So you get -3 minus the -8, which is really -3 plus 8. So you get 5, but here's that negative in the middle. So you get -5j, and this guy's 0. So you just get -5j as being the cross product between u and v. And so here it is. And if you choose to write the answer, which is the cross product between u and v, in column format as opposed to unit vector format here, then you could write it as 0, -5, 0. Now, what I said at the start of the video is that the cross product between two vectors gives us a vector that is perpendicular to the original two vectors. Well, how would we check? We know that two vectors are perpendicular if their dot product is equal to 0. So we can take u cross v here, which is this vector, 0, -5, 0, and dot it with u first, and then dot it with v first, and in both cases we expect to get 0. And that's in fact what we get, because u dot u cross v would say 3 times 0, 0, plus 0 times -5, 0, plus -4 times 0, 0, and therefore 0. And since u dot u cross v is 0, we know that u and u cross v are perpendicular, and you can similarly check that v and u cross v are perpendicular. Alright, cool. I'm done here, and the next couple of videos will be about the equation of a plane. First will be the derivation of the equation of a plane, and then at least 2 examples to follow. Yeah? Alright, cool. Look out for that. Otherwise, I am done here. Keep watching. Take care.